All right. If you guys get your notes out, we're just gonna hit the ground running. We'll review homework at the end of class. Um, so the plan for today, we will go over the next set of notes. We are gonna do some problems on the walls. You probably saw your name on or your names. So that'll be good practice. I think it was page 5 of the notes we didn't do last time, where I want you guys to practice drawing a function, making a table, do the inverse, and find the equation of the inverse. That's going to be our homework quiz on Monday next week. We'll have our first homework quiz Monday next week, and you actually are going to be doing the homework quiz, a practice for homework quiz, something like that, right today. So when we do the homework quiz on Monday, it won't feel brand new. Like you'll know what to expect. Maybe I'll start doing that more often. That might help you guys with homework quizzes, so it's not too much of a surprise. Maybe just like some group work beforehand. Anyhow, the notes, let's talk about right now. Sorry for the glare, it's just the time of day. So I'll do my best to use bright colors so you guys can see what's going on. So let's look at 525. This is page 7, by the way, of the notes. Look at the graph at the right of the function and its inverse. If P is the function, Q is the inverse, can you tell which is which, why or why not? So notice I put P next to the one that's pointing up and Q next to the one that's pointing to the right. But I just kind of randomly did that. I can make that Q and that P. So here's the thing. Can you tell? The answer is no. And why not? That's because the original and the inverse are interchangeable. I'll explain what that means in just a moment. But that's the real reason why I can't tell. Um, the original and the inverse are interchangeable. So take a look at the vertical one. Actually, let me put it back as P and Q. I mean, again, that doesn't really matter, but that's what I had originally. What kind of function do you think P is? The one that's pointing up and down. Cube. Yeah, it's cube. Yeah, it's not exponential, it'll be cube. And so the parent function will be x. So P of x will be something like this here. And you guys remember I gave you guys that nice table for the final exam. It looked like this, right? It had all these different functions with H and K in them, right? You guys remember all that stuff? So I have in the top right corner. So A, H, and K. Looking at the graph of points up and down, what do you think H is? What do you think K is? Like, how far do you think that's gone? Because x cubed, by the way, is supposed to look like this. That's supposed to be y equals x cubed. But clearly it's shifted. How is it shifted, would you say? One, go ahead, John. One to the left or right? And also how about up or down? It's gone up, right? Because the center is not at the origin. Where's the center located at? Negative one comma one. And the a value, it's not, it's a little hard to tell what the a value is. We're just gonna assume a is one. I'm just gonna assume it's one. Um, so p of x, all right, go somewhere. Yeah. Ooh, good point. Okay. Actually, I didn't see that. Good call. So it is going by two. So actually, where's the center of that graph? Truly, not negative one comma, but negative two comma one. Thank you for catching that. So I'm gonna write like this: x plus two cubed plus one. So that'll be p of x. So what would I expect for q of x then? How do you think I'd write the equation for that? Let's write out the steps. It's gonna be the inverse, right? So you can make a table, or you can ask yourself what is happening with the original. So let's write out step by step what's happening with the original. For the original equation, original function. Sorry, original function. What are all the operations happening? So if you look at p of x, okay, I'll call it the original for now. The q could have been the original also, it doesn't really matter. But I do know their inverses. And how do I know their inverses? Because actually, I should have stated that earlier. That's my fault. How do I know they're inverses? Does y equals x cut that in half? Does it go right through the middle? It does, yeah. So P and Q are symmetric about what again? About y equals x. So whenever y equals x goes right through the middle, that's going to mean that they're inverses of each other. So that's how I know. I should have said that earlier, so that's my fault I didn't do that. But let's talk about the original function, what's happening. Alex, go ahead.
Stop question, but why are we using P and Q?
Because they felt like it. Use F and G. If you want to use F and G, go ahead. I don't care. Or A and B. Or you can use your initials, A and K. I don't really care. So that's trivial. So the original function, what are the things happening to x on the original function? What's the first thing x sees? You're adding what? 2, right? And then what's the next thing it experiences? It's cubed. And what's the third thing it sees? Right. Okay. So those are the things that are happening. Okay. So for the inverse, I have to expect the opposite. And, ooh, I ran out of space. Hold on. There we go. Okay, for the inverse, what's the ops? So I have to reverse the order. So I'm going to subtract 1. Then what's opposite cubing? Cube root, good. And then if the first step was add 2, it'll be subtract 2. So if I were to write that, it would look like this. Let's go red. So it'll be x minus 1 cube rooted, and then minus 2. Which kind of makes sense, right? Because I know it's hard to tell, but look where that center is. Where would you say that center is located? Or what are the coordinates of where I'm pointing at? What's the x coordinate of that? No, the center. So it's gone 1 right. And how far down? 2, right? So it's 1, 2. You have x minus 1 minus 2. So it makes sense that we're seeing that we're seeing those coordinates line up with the center. So, but could I make q of x the original and p of x the inverse? Sure. It doesn't really matter. They're totally interchangeable. You didn't have to call p the original or the one that's up and down the original. You could have labeled it however you wanted to.
Do sine over Q of X?
Oh, you mean the symbol -1? No, because you're giving q of x its own label now. But actually, what I could have done, I could have done this. Exactly. Yes. Yes. I could have done that also. Sometimes we like to use 2 different letters to avoid that confusion. Or if that's more confusing, then we could just stick with 1 letter and do the -1 symbol. So this is just to really kind of repeat what we did last class, which was 2 days ago on Tuesday. Again, p of x, you can make it either one. I made it the one that's going up and down and add the other one there. So, all right. Okay, now we're gonna do another one together. I'm gonna give you a hint. This one's a linear function. This is linear. So linear means y equals mx plus b. We know this, right? So let's write an equation for what we see in the table. And then let's make a table for the inverse. And that's how are they related? And then we're going to write the equation for part D. And then we're going to solve. Oh, I'll talk about E in a little bit. Okay, so what's the slope here, guys, for the table? What do you think? If I find the slope, what would I get? 6, good. Yeah, good. So y equals 6x plus b. I like that. Actually, let's get in the habit of writing as f of x. And let me get rid of that right there. That's being a little a nuisance. Okay, how do I find the y-intercept? What would I do? Plug in 0 for x, correct. But oh, actually, no, I can't do that. Sorry, that is the y-intercept, but how would I use the table to help me find the y-intercept? Plug one of the points that I can plug in any point I want. Like which point do you want to plug in? Could be any one of these. Let's do the first one, okay? We'll see that one right there. So -5 equals 6 times 1 plus b. What's b gonna equal? Should be pretty easy. -11, actually. You did -5 plus 6. Okay. It's all right. Shake it off. So y equals 6x minus 11, right? And does that make sense for all the other points? It does. If I were plugging 3, 7, 5, 19, 7, 31, it all works out. So that's part A. Does that make sense? So I found the equation.
Oh, never.
Actually, I'll use f of x. Let me go back again. So I was doing f of x. What's your question?
If it's negative. Oh, is it? Never mind. Sorry, I thought it was -6. It's positive 6.
It's positive 6. Oh, you're doing the mental math. You're just getting confused. That's all. Okay. All right. How do you do the inverse table? We talked about this already. Just switch it to. Yep. Just swap the columns. That's the definition of inverse when you're switching. So that's easy. And how are they related? You swap x and y. That's super easy. Swap x and y. All right. So questions so far? Pretty good. All right. Part D. You use that relationship to find a shortcut for changing the equation, the original function, into its inverse. Okay. So I could actually just do slope again. Or I could just do this. Let's do opposite operations. Let me do it up here beneath the space. I'll do part C up here. Sorry, part D. Okay, so right now we're multiplying by 6. Then subtract 11, right? So how would I do the opposite? What would I do first? Go ahead, Alexander.
First you have to divide by 6.
Nope.
Oh, sorry,
Reverse.
sorry, you add 6
Okay,
and
good.
then you
Nope.
divide by
No. Try again. Add 11.
11, not 6. Sorry.
Okay, good.
Then
Okay,
divide by 6.
okay. Good. Good way to redeem yourself. All right. Yes, John, go ahead. Swap x and y. Swap. Sorry about that. Let me write that a little better. Yeah. Swap. Oh, you're welcome. Okay, so that's part D. And the slope is 1/6 if you were to calculate it. Okay, now let's look at part E. And then part F we'll verify afterwards. For part E, you could actually have done it a little differently than we did for part D. Here's what you could do to find the inverse. When you're asked to solve, you could just swap x and y and isolate y. Okay. So let's swap x and y. Okay. Then you could just solve it, right? You still get the same thing. So you could actually approach inverses in this manner. That's actually how I used to teach it out of the old textbook. But CPM kind of forces you to understand the operations, which actually I like. I think you should do that. But you could just do this as well. Take the original function, swap x and y, and then solve for y. So we're going to actually practice that on the next page, because ultimately you're going to want to do that, because that is actually a more efficient way than just always saying, oh, well, let's write all the steps and then let's reverse the order and do the opposite operations. I mean, it's good. There's nothing wrong with that. But ultimately, you're going to want to get better at just doing algebraic like I just did for part E. So again, for part E, take the original equation, swap the x and y positions, solve for y after you swap. Lastly, for part F, justify that they're inverses of each other. You could do this. I showed you guys a kind of a wacky way the other day, and that was a little premature. You could just do this. Let me write the equations again. So can I clear the screen? Yeah. So what was the original equation again? The original equation was f of x 6x minus 11. And what was the inverse again? That was, all right, thanks. X plus 11 or 6. So what we could do is plug in 1 comma -5 into f of x, then -5 comma 1 into f -1x. So if it works, then you know they're inverses because you reversed it, right? So if I were to plug in -5 for y and 1 for x, does it work out? Yep. And if I reverse those coordinates and plug in -5 for x and 1 to the inverse, does it work out? And it does, because 1 equals 1. Or 1 equals 6 over 6, which is 1 equals 1. So that's one way you could verify, is take a point that satisfies the original, reverse the coordinates, plug into the inverse, and it should work out. But the way I showed you guys on Tuesday, where you plug the function to the other function, that's the more sophisticated way of doing it. I didn't. I shouldn't have done that on Tuesday. I was a little too premature. But we'll do that again today. All right, so let's look at 541. I'm going to do part A. In your table groups, have you guys do B, C, D. You can actually divide and conquer. I was mixing my words. You can divide and conquer because every group has at least 3 people. So after I do part A, maybe have someone do B, someone do C, someone do D, and then kind of check each other's work. I'll put up all the answers anyway. But let me show you how part A is done. So again, switch X and Y and then solve for Y. So let's do it right now. X equals 2y minus 1 cubed. So that's the first step. By the way, on a homework quiz or on a test, that'd be worth 1 point, doing the swap. So you guys see how I just swapped them, right? Then the next step is to solve for y. Now, remember we had solving literal equations where we had to like get one letter in terms of another letter, right? We did it like several times out in the final exam. We had twice on the unit test. That's why we're so adamant about it, because you have to be well versed in that process now. So I want to get y by itself. That's your goal. All right, I want to get this by itself. What do I have to do to get that by itself? What's my first algebraic step to get y by itself on the right side? Don't cube yet. Alexandra, what does he say again? Yeah, because if you cube root, you got to cube it to 2, and that's gonna make it more messy. Let's not do that. Let's get rid of the 2 first. I think that's why CPM kind of asks you to reverse the steps, because it helps you to kind of see the algebra a little better. But you see how this is a little cleaner now? Now, is it easier to cube root now? Yes, much easier to cube root now. So let's cube root now. So you get this, right? And then one more step. What's the last step?
You plus add one.
Add 1 to the other side, exactly. So it's 1 plus that junk. So this would be like a 4-point problem, by the way, on a test or homework quiz. 1 point for each step. So you can see, like, my rubrics are very straightforward. There's no debate about it. 1 point for each of those steps. And now, of course, if you mess up an algebraic step, everything else looks fine. Of course, I'll give you most of the other points, right? Not a big deal. All right. Given what I just did, do the same thing for B, C, and D. If you want to just work independently, go for it. If you want to divide and conquer in your table groups, go for it. Totally fine. I'll show you guys the answers in just about 3 minutes. Switch X and Y, solve for Y. That's all we're doing. Part D is kind of doozy. All right, here we go. Don't look. I think I did part D right. Which part? Sorry. Part B or part C or D? I may have made a mistake. Hold on. X. No, I think I got it. What did you have, Jazza? Yeah, so you did swap, and then you want to subtract 3 first.
Wow, I
don't think that was-
did not get it.
That's why it's and then square both sides and have 2.
Wow.
So just swap the 2 and 3. So you switch up to like then your goal is to get that. So you should move it to
Negative one. Sorry.
Okay, oh. Candy's multiplied by.
How is Alex
Let's see. What is that? Why would Perfect. Okay, just gonna square some around. Don't get boilers.
Oh, it's.
Okay. So I think it's the same thing, or I think. I'm so lost.
Mine first.
I got this one.
That's wrong. I did something wrong?
I don't know, but something seems wrong. It's 4 of 3.
Yeah, so you divide by 4/3, which is the same thing as multiply by 3/4.
Oh.
So reciprocal.
Okay.
Yeah.
Yeah.
Yeah, it's the problem is that for fractions, you guys learned it 4 years ago. And
Yeah.
pandemic, so you guys probably full of fractions.
He made our, we made our ticket good. And. Yeah.
Yes, yeah, I mean, would you want to do one?
Like you can.
It's fine. You just want to be careful. Better write. It's better than well, you divide by fraction,
No.
then you divide by fraction. That's what creation should be.
What? You should be in the car. Yeah. No, no. Oh my gosh.
Oh, this is so cute. What's over Q by itself? What's Q is fraction? So it doesn't matter. It's the same thing. How did you? Yeah. What you don't want is you don't want to put it in the bottom, right? You don't want to do that. Then you want halves. It is. So yeah. Go ahead.
How did you get from that,
I know. It's
from that to the bottom?
Which one's CRD?
C.
Okay, so the first thing is I subtracted 20.
What's that?
Subtracted 20.
Yeah,
Then divide by 3. And then multiply by 2. There's a 2 there.
yeah. Oh,
Then add a 9.
okay.
So it's undo.
Follows this like how it is.
Yeah, okay. This is good. I'm glad you guys are making mistakes. We want to make mistakes now. Yes, exactly. Subtract the 6 first. But divide by 4 thirds, no different by 3/4. Same thing. Correct. Correct. Questions here? Are you doing okay? Okay. Okay, so I do have the answers up. Hey, let's not play Wordle or whatever you guys do or Scrabble. Just go away. You don't need it. Oh. Oh, no. What was this game? Eight Wordles? Alright, well, put it away when we skip back. Yeah, acceptable. Okay. So you, are C or D? Okay, good. So you subtract the 20, love it. And then you divide by 3, perfect. Okay, then you want to get, so your goal is to get this by itself, right? So I multiply by 2, to put the 2 to the left of it. And actually, if you want, you could leave it like this. It's the same thing. You're almost on 3. What do you do about negative 9? Exactly, right. That's good. Right.
Mr. E.
Yes, I think we're almost ready to move on. You guys doing great? Yes.
I wrote my D like that, but that's technically right.
You can't put the 3/4. Hold on, wait. Oh, I see. Wait. Oh, yeah, that's fine. Yeah, that's fine. Sure. Yeah, just make sure it's extended, so the 4's gotta be, you keep that whole thing, right? Yeah,
That's tolerable.
sure, that works, yeah. That works. Lois, you have a question? Okay, guys, last one, let's talk about D. So you see how I moved the 6 over? Because the plus 6 is the first we should move. This is the easiest thing to move. The next easiest thing is the 4/3. What's the opposite of multiplying by 4/3? Multiplying by its reciprocal. That's why I get 3/4.
Alright.
Okay, so that's 2 steps. We've got 2 more left. Cube, we'll do cube roots. And lastly, I have a -1, +1.
Oh.
So boom, boom, boom,
Oh,
right?
This probably, Mystery's probably not gonna like this, but I just, at first, I multiplied by 3. And then
That's
I
fine.
went back and divided by 4.
There's nothing wrong with that.
Than doing the reciprocal.
Whatever makes sense for you. It is an extra step. So the opportunity for chaos there is a little bit greater, but it's up to you. All right, you guys did fantastic. That's awesome. Okay, let's look at 542. And then I want to just briefly talk. I'm not gonna do all 545. I'll just do one part of it, and then we'll do the problems on the walls outside, and then you guys can work on homework after that. Yeah, because we go to 150. We have plenty of time. Okay, let's look at 542, guys. Okay, 542. Talia has an idea for checking the functions f(x), g(x) or inverses. She thinks of them as stacked function machines. That's fine. She starts by choosing an input to drop into f of x. Then she drops the output from f(x) to g of x. If she gets her original number, she's pretty sure that the 2 equations are inverses. What do you think of her idea? It's good. It's great. That's exactly what you want. The reason why, well, let's go through part B and you'll see why. Okay, so let's try it. So let's plug in a number. So let's plug in 3. Tell me what we get when you plug in 3. Now, let's plug in 3 into G. So it comes back full circle, right? And that's what we want. So what this tells me is that f of G of 3 equals 3. Also, if you reversed it, same thing, you still get the same thing. The bottom line is this. This is the key takeaway. When you stack the original and inverses with each other, whatever you plug in for x will be your output once you are done.
That's. Never mind.
Okay, so when you stack the original inverse with each other, whatever you plug in for x will be, oh, terrible grammar. Will be your output once you're done. So if I plug in 3, I expect 3 to be coming out. If I plug in 4, I expect 4 to come out. If I plug 5 or 6, whatever, it doesn't matter. It should always just come out the same way. So, all right. So hopefully that makes sense for that one. And when you stack, we stack them. If you look at the bottom of the page, Lincoln, can you put your shoes on? Just stop talking. Thanks. Okay. All right, let's go to the bottom. All right. So composition functions. So when you have something like this here, that's called a composition. Okay, that's called a composition. Sometimes it's written like this. Or sometimes written like this. Or sometimes written like this. And it looks like fog, I know. It's kind of weird. These are all the same. No, it's not a degree. It's just a little circle. That's all it is. When you have f and g in a little circle in between, or if you have f in a little circle g and g of x, or if you have it like this I think is better because you're seeing that g of x is going into f. They're all the same. These are all the same. All I'm really teaching you guys is notational fluency, so you don't get confused and move on to pre-calculus. Or for those who are doing juniors who are doing ACTs, and I think some of you guys might be doing that. ACT is changing, by the way, in April. If anyone is doing it, or SAT, maybe they don't do that. I don't know. But ACT, I have seen this. Just so you're not confused, that all means you're playing one function to the other. That's all it means. You just gotta know how to read all of them. I don't know. I haven't thought that far ahead. That's like 3 weeks from now, so I don't know. Or 2.5 weeks. I don't know. So let's actually try it for 5:45 part A. I'll just do part A only, and then we'll go outside and do some work on the walls, and after that, come back and you can work on homework. And if you have questions on the homework from last night or 2 nights ago, we could talk about that too later. Okay. So here's how we do it, guys. Part A. F of g of x. So you're going to replace x with g of x for the f of x equation.
So where f of x is, you put the equation of g of x and then equals the f of x.
So yeah, let me do it down here. Correct. Yes. We're not there yet. We will get there. We have to use this process for logarithms also to understand it. Okay. Okay, do you guys see what I just did? Hopefully the color coding helps. I'm kind of patriotic. In honor of our death of our former president, Jimmy Carter. Anyway. He was actually, when I was born, he was president, so that's kind of cool. But yeah, if I remember, I was like reading Reagan's book. But anyway, f of g of x. Okay, so remember I placed x here with g of x, right? I replaced x, g of x. So now what you're gonna do is substitute 5/3 x plus 25 to that parentheses. You're gonna just snatch that expression and throw it in. Just gonna throw it in there. I think the more I think about it, I think a delta math assignment might help you guys with this too, to kind of see the repetition.
So
Mhm.
when you do that, when you put g of x,
Mhm.
do you just put the 5 over?
Yes.
Okay.
Yes, the whole thing. Yes.
So just like what if what's it called things that's like, I don't know the words actually. It's like you could do elimination, you could do.
Oh, substitution.
Yes.
Yes. 100%. It's very similar to substitution. Yes. Yeah, when you have systems of equations, that's what you're talking about. Yes, 100% correct. Okay, so you guys see what I just did? No. What we're doing is we're trying to we're not trying to find the inverse, we're trying to verify that it inverses. It's a different process. Now, what you could do, Reggie, you could find the inverse of this, and if it equals that equation, that's another way of verifying that you can do that too. But I'm just showing you a newer process, a more sophisticated process, just so you know what it looks like. What you do is you take this x here, throwing it out, and what are you putting in place of it? This entire thing is that x. And now you work out the algebra afterwards.
So you keep the x of the g of x in there.
Of course, right. So when I work out the right side, Jasmine, go ahead, yes. No, just the right side I'm working, I'm looking at. So if I work on the right side, I should have 3/5 times 5/3 x plus 3/5 times 25 minus 15. If I work it all out, those cancel. And that becomes 15 minus 15. Well, what's 15 minus 15? 0. And you just get x. So what happened is that we see that by doing f of g of x, whatever where my input is, my output will always be x. Just like we saw on the previous page. Whatever I plug into x right now, let's say I plug in like a 3.
Where'd you get the 2/5?
No, that's 3/5. Which part are you talking about, Tom? Here?
Because there's only one of them, how, you get two up there.
Oh, I distributed 3/5 inside.
Oh.
I distributed 3/5 and I worked it out. So I did 3/5 times 5/3 and 3/5 times 25.
Yeah.
That's what I did up here to round space. That's what I
Yeah,
did. No, good. I want you to ask that because there's a lot going on. Good, ask that question. So I did 3/5 times 5/3, which canceled. I did 3/5 times 25, which is 15 if you work it out. That's 75/5, which is 15. 15 minus 15 cancels out as well. We would just ask. So again, what's happening is that whatever I put into the original, whatever I put into one of the functions, what if I plug in a 3 here? What happens if I plug in 3 here? What do I get? What's 5/3 of 3?
5.
5 plus 25 is. Now plug in 30 here. What's 3/5 times 30? You should get 18 minus 15, which is 3. Well, I started with 3 to begin with. So I'm getting back to the same thing. Whatever this output is, when that comes into the other function, you get the same thing. Okay. That's good. That's precisely what I wanted to have you. So we're not gonna do B and C. Let's not worry about it. We could do it next week or another time. Let's go outside. There's a marker and it's all color coded. So pick the marker for your group and your names are out there. And oh, you also need to bring, okay, I'm gonna ask for you guys to kind of have roles somewhat. So probably one person can do, whoever feels most confident probably should go about doing the work. But have one person bring out their packet. You're gonna do page 5 and have one person bring out their phone. You can take pictures or record video. I don't care. Just don't do anything else on your phone. Okay. But I want you to at least take a picture and then share that among your group members. You can text each other or AirDrop, whatever you guys use for communicating. So guys, let's go to the walls outside. Let's get up. So page 5, you need to bring this with you. No, it's a notes. Page 5 of the notes. Yeah, just one person should bring out the packet, just one.
All right, Lois. Lois.
I color coded this.
When is the real us? Summer?
say the right equation inverse, and then you guys go back. You guys start homework out here.
Thank you.
Yeah, homework is just over to a student athlete.
I said we talked for my. Your what? Oh my god. What's the theme? Blackout. And I will be doing that. Oh, I get it. Yeah. I get it. Literally. Okay, that's all right. Or you can wait for your. No, I.
All right, yeah, you guys like fantastic. You guys have 26 minutes. You guys are putting off the homework. Especially go out and watch the college football playoffs tonight or NFL playoffs.
But when are the first?
This weekend. Saturday. Notre Dame and
Notre Dame, Penn State, and then.
Yeah.
And,
Yeah, I was gonna say-
Bro, those are both five.
Like how? I mean, wait, is he talking about?
Yeah.
one?
Texas is
You
getting.
should both. Oh, I haven't the keep on my word. Is it very deep? This one.
Oh, oh my God.
I like to figure out.
I didn't, yeah, because it doesn't.
I'll show you.
I look like
So you know.
that's like the move though, so it's fine. Do what I can do.
That's what it's about.
Like I'm not, no, I.
That's why, that's.
Oh. And I told Maggie that too, and I was like, I don't know if that's what God is saying, but like, I don't care, and she was like,
Yes, good, that's what you wanted to guess, go to the 60th roots.
bad,
For the 60th,
questionable maybe.
oh, we got reverse. 1.5.
Oh, you did that.
You have to do,
He's like.
so that's negative 60, right? You have to grade both sides and negative 60. You gotta take this. That's confusing. Yeah, this is the part you have
$5. But you must have been there, so you're 18.
Why do you name one?
2 years.
What's negative 60?
She told Dana.
Oh my God.
And then you can use that to, the different systems.
That means it's.
6 years from now, it's 25 plus 5.
Yeah.
And then you put in 6. Right, 6 years. And then you continue on, it's 1.2.
Oh, yeah, that's a.
Wait, so yeah.
By a suit.
Which, oh, you added it. Okay, okay.
Sure, yeah, yeah.
Not, fuck you, not.
No. It's just unrealistic. No, I know, I'm saying full of it's just unrealistic expectations.
Yeah, so, what you want to do is you want to do, was it the interest one, right? Yeah.
When did you hear that?
No, the p value is gonna be, this is your initial value. And that's the value.
Maybe.
Oh, you're,
Maybe.
yes.
Oh, yeah, everyone. Oh. Allow it.
Allow it.
Well, just allow it.
I don't know about these 25-minute classes.
R over N.
Is that your?
Yeah, see.
Non-stop.
Thank you.